been drooling over AI models like they are the second coming. But the real choke point is not code. It is a machine that shoots tin droplets with a laser inside a vacuum chamber to make light we can barely even reflect, so we can etch wires smaller than bacteria onto wafers. We then stack like pancakes and cool with plumbing. That is the bottleneck. That is a $10 trillion hostage situation, and it's all sitting on a fault line, literal and geopolitical, called Taiwan. So the core question for today's video is, what actually constrains the AI century? Who controls it, and what happens when that control is disrupted? Because this is not a normal industry. This is a physics regime weaponized as an industrial policy. It is a global economy dangling from a single point of failure. Let's start with the God machine, the ASML EUV scanner. Calling it a tool is cute. It is a cathedral made of vacuum chambers, lasers, mirrors, and control loops that would embarrass an ICBM guidance system. You want 3NM logic, you want H100s, Blackwell's, Apple's next M series. You're buying protons at 13.5 nanometers created by turning 10 droplets into a microstar 50,000 times a second. Not metaphorically, literally hotter than the sun's surface. So the technology that we are using to make these AI chips is hotter than the sun's surface. It's called plasma. And that's happening every second all day. The creation of that plasma. So here's the part no one outside the weeds internalizes. That light exists at all because a San Diego droplet generator spits 10 at 70 meters per second. A pre-pulse laser slaps the droplet into a disk, and then a megawatt class CO2 pulse vaporizes it into plasma that spits out EUV in a narrow emission band. Miss your timing by microseconds, you get the breeze, fouled mirrors, and a multi-million-dollar downtime event. Power fluctuates a bit, you print randomness into your transistors. The entire chain runs at 50 kilohertz in high vacuum with mirrors that have to be flatter than atoms. If that sentence did not make your blood run cold, then think about it for a second. Now, the later is called the TRUMPF's CO2 behemoth. People think laser and picture an industrial cutter. No, this is a 40 kilowatt average megawatt peak monster built from a seed oscillator and a football field of amplifiers folded inside a cabinet. Hundreds of thousands of parts, exotic gases, diamond windows, RF generators, and it has to do the same thing with the same shape 50,000 times per second with tolerances so tight that normal engineering language does not even capture it. This subsystem alone is a supply chain with its own supply chain. Then the mirrors, Carl Zeiss SMT. You cannot use lenses at 13.5 nanometers. Everything absorbs that light, glass, air, you name it. So you bounce it off Bragg stacks. Layered molybdenum and silicon with thickness turned to the quarter wavelength. So constructive interference gives you something like 70% reflectivity per mirror on a good day. So do the math. 70% per bounce through a 610 mirror train. You bleed photons at every stage. That is why the laser needs to be absurd. That is why the collector mirror has to survive being bathed in plasma speed junk. That is why the mirror substrate has to be thermally dead, 0 Dur level, because a few microclevin expansion trashes your patterning. And just when the industry stabilized at 0.3 and ASML and Zeiss pushed high NA to 0.55 with animal form optics, 4x in one direction, 8x in the other, because geometry was starting to rebel. Bigger mirrors, steeper angles, faster stages, wafer stages, 8 Gs, practical stages doing 32G. This is not manufacturing. It is precision artillery conducted inside a vacuum lab, integrated with a mechatronics ballet that can't ever miss a beat. You wonder why there's no competitor? That is why. You don't enter this market. You spend a decade building relationships with obscure gas suppliers, niche diamond fabricators, ultra pure material vendors, bespoke metrology toolmakers, and then you stitch them into a machine that is itself a global economy. Tacit knowledge alone is a moat. Thousands of engineers who know how not to turn $1 billion scanner into a very shiny brick. Nikon and Canon did the math. They walked. China did the math too, even if it will not admit it publicly. You can steal drawings, you cannot steal 20 years of debug logs and instincts. But owning the brush does not mean you can paint. That is TSMC. Intel can buy the same EUV scanners Samsung can. Show me the yields. The dirty secret at 3 nanometer isn't transistors, it's statistics. Photons arrive in discrete packets, and when you're trying to resolve lines at a single digit nanometers, the randomness bites. Shot noise creates bridges and breaks. Chemical resists behave like moody teenagers. Bake temperature, development time, source, dose, resist chemistry. This is empirical science. It's recipes backed by staggering amounts of inline methodology and closed loop feedback. TSMC wins because it sees more wafers, spots more defect nodes, trains more models, adjusts more knobs. Volume begets data, data begets yield, the yield begets more volume. That flywheel is brutal, and it is why every AI bellwether books TSMC capacity first. And then packaging. Moore's law is not dead, it just changed jobs. If you want AI performance, you're not getting it by just shrinking transistors. You're getting it from putting logic and HBM side by side on silicon interposers with microscopic highways. And that's just a footnote. So there's something called COWOS. And for those of you who don't know, that's part of Taiwan Semiconductor Manufacturing Company. It's called a chip on wafer on substrate. It's a 2.5D advanced packaging technology from TSMC that integrates multiple chips like GPUs and high bandwidth memory onto a silicon interposer, which sits on a substrate, creating a system in package for extremely high performance computing, AI, and data centers by reducing communication distance and increasing bandwidth. This wafer level integration allows for massive density and efficiency, crucial for demanding applications, with TSMC being the primary developer and provider used by major players like NVIDIA and AMD. So that is the production method for the frontier. TSVs through silicon interposers the size of small tablets, word page control, CTE mismatches, and my favorite, liquid cooling bolted directly to the die because you're running 100 kilowatts in a rack and the heat flux says physics would like a word. You don't actually stand up a COWS, which is a chip on wafer on substrate. So yeah, so I hope everybody, is liking this so far. So, but yeah, you have to line up the customers years in advance before you can set up one of those chip on wafer on substrates. You have to lock tubing, materials, adhesives, and reality models into a flow where failure means your $1 billion customer shipment bows in the oven. Layer in the human piece. TSMC's round the clock R&D culture shifts hand off experiments so the iteration cycle never sleeps. That is not a slogan. It is literally process velocity. One day on paper, 3 learning cycles in practice. You try to replicate that in Arizona under US labor law and expectations, you will get good fabs eventually, but you will not get the same tempo. That delta in tempo shows up as yield spread. Yield spread is profit spread. Profit spread is strategic leverage. Now let's talk physics walls. Gate lengths and oxides are flirting with the angstrom era. Quantum tunneling stops being a nuisance and becomes a lifestyle. Hence the shift to gate all-around nanosheets. Slice the channel into ribbons, wrap the gate 360 degrees, clawback electrostatic control. Sounds simple in a keynote. In reality, you're growing stacked SIGE layers, selectively etching out sacrificial germanium, leaving hair-thin silicon ribbons suspended in space, then wrapping them with metal without collapsing anything. Every step is a failure mode. Every failure mode is a yield hit. This is where good enough is bankrupt, because you either have to nail it or the wafer is composed. So where does the global system break? Taiwan. Taiwan is where it breaks because Taiwan is the silicon shield. It is a hostage strategy, whatever you want to call it. The world's most valuable, irreplaceable manufacturing capability is concentrated in a place the PLA rehearses invading and the US rehearses defending. So a lot of you may not know what a PLA is. So what do you think that is? I'll give you a second to think about it before I obviously give you the answer. So it's basically the People's Liberation Army of China. So they're rehearsing invading, and the United States rehearses defending. It's not just phones and cloud GPUs at risk. It includes aircraft radars, missile guidance, satellite payloads, energy grid controls. Modernity runs on logic and memory, and the frontier nodes are overwhelmingly Taiwanese. Cut that artery, and it is not a recession; it is a reset. 10 trillion off global GDP is a conservative number if the outage lasts more than a quarter. Automotive stops, cloud capex stalls, consumer electronics goes dark. Defense stockpiles get raided for chips, and then you discover your smart munitions are only as smart as your procurement lead times for Hisshinchu, which is in China. Actually, no, Hisshinchu is in Taiwan. So yeah, here's a nasty paradox: the U.S. depends on Taiwan to defend Taiwan. F-35s, AEGIS, Patriot PAC-3 upgrades, hypersonic programs, advanced FPGAs, and ASICs often fabbed at TSMC. Yes, there is legacy capacity domestically for older nodes. That will not cut it for the bleeding edge. A protracted conflict runs those inventories dry. You cannot surge 3 NM yields into existence. Sorry to burst your bubble. You can't surge high NA tool install bases. This is deterrence by dependency, and it is starting to fray because everyone knows it. So what is a playbook? Do not fantasize about self-sufficiency. Think portfolio construction for civilization. Diversify nodes, not just geography. You don't need 3 nm for everything. Hardened supply of 28 nanometers, 40 nanometers, 65 nanometers in allied territories for industrial control. Automotive and defense sustainment. That keeps the lights on when the frontier gets disrupted. And those 65 nms are like process technologies for semiconductors, and it's widely available in Taiwan, South Korea, Japan, US, and Europe. But they're not as good as the ones in Taiwan. So build redundancy where it matters. So 1 or 2 advanced packaging mega lines outside Taiwan with pre-booked anchor tenants and co-developed thermoflows. Packaging is a current bottleneck for AI, not just lithography. If you cannot bond HBM at scale, your GPUs are doorsteps. And then stockpiles of critical FPGAs, high-end RF, space-grade memories. We have to buy time with spares. Not forever, just 12 to 24 months. Enough to ride out a blockade and buy diplomatic maneuvering room and not have to choose between phones and missiles. And we have to also fund the boring stuff. Photoresist, pellicles, EUV collectors, ultra-pure chemicals, vacuum pumps, RF generators, sanction-proof them across a coalition. One supplier gets embargoed, your scanner is a paperweight. And accelerate high NA capacity but don't believe timelines. Those EXE 5000 installs are moonshots with revenge. Expect slips, plan around them. If someone's roadmap assumes linear progress, they are selling you a pitch deck. Export controls with teeth and logic. Deny the Apex tools that compress learning curves, but do not kid yourself. Second best tools still turn into weapons programs. Structure controls to slow adversaries' packaging, thermal, and yield learning, not just their transistor density. And yes, onshore selectively, but be honest, you're not copying Taiwan's culture, geology, or 30 years of muscle memory in 5 years. If you're buying partial resilience, that is still worth doing. Let sanity check second and third order effects. If Taiwan goes offline, cloud growth caps at whatever inventory exists. That means AI model training slows to a crawl, startups die first, hyperscalers hoard, software innovation turns into rationing. National security planning gets ugly. War rooms get pulled into the procurement trenches. The bottleneck becomes a strategy. You redeploy industrial policy from slogans to emergency triage. Inflationary shock. Everything with a chip goes scarce. Automakers idle. Medical devices face lead times nobody signed up for. Politicians blame greed until their advisors whisper the words EUV mirror reflectivity curve. Markets. Your semiconductor ETF becomes a referendum on single points of failure. Firms with multi-node optionality and packaging capacity outperform. Everyone else represses to reality. And if the worst does not happen, the pressure still reshapes the map. The CHIPS Act is not charity, it is insurance. Japan, the Netherlands, Germany, South Korea, they all pivot to being pieces of a redundancy puzzle. Not cheap, not elegant, necessary. The real cost is the premium you pay for optionality when physics will not let you move fast and break anything. What should you watch as leading indicators? ASML backlog composition, especially high NA shipment, schedules, and any hint of source power or collector lifetime issues. If those slip, the entire advanced node roadmap wobbles. TSMC's stand-up wafers capacity adds and the mix of interposers and HBM generations. As the packaging queue extends, AI deployment estimates are fantasies. Photoresist and pellicle breakthroughs for EUV stochastics and defectivity. As stochastics don't improve, yields top out and costs climb. United States, Europe, Japan subsidies moving from fab shells to process qualified lines. There's a difference between ribbon cutting and risk absorption. China's domestic litho ecosystem for DUV, multi-patterning, and advanced packaging. They don't need EUV to become a serious spoiler. If they nail packaging, so they have to nail IO as well. So they have to nail the input output packaging and cost on a 14 to 20 nanometer for AI inference and military systems. Defense procurement language around assured microelectronics. If it's not backed by funded multi-year contracts with explicit no targets, then it's theater. Let's come back to the core. The bottleneck isn't mystical, it's cumulative. It's capital multiplied by physics, multiplied by tacit knowledge, multiplied by a global political compromise that pretends we can run the 21st century on just in-time miracles from a small island under constant threat. You want to reduce risk? You have to overpay for redundancy. Accept lower margins, live with inefficiency, and stop outsourcing your survival to quarterly guidance. There is an uncomfortable truth at the center of this. The moat is unbreachable on startup timelines. It's not unbreachable on civilization timelines. If you think in election cycles, you will fail. If you think in 10 to 15 year industrial